Good morning, folks, and welcome back. Today we're doing count good nodes in a binary tree. Given a binary tree root, a node X in the tree is named good if in the path from the root to the X there are no nodes with a greater value than X. Return the number of good nodes in the binary tree. So there are 4 good nodes in this tree, with X being, node X is good if the path to that X doesn't have a greater number. So 3 is good because 3 and 1 are both lower. 1 is bad because 3 is greater than 1. Okay. So I want to drill down, keeping track of the highest number at each node. The highest number on the path to each node. And then I want to return from that node a 1 if there are no greater numbers before that node. In addition, I want to return any counts that came from following nodes. So we're going to do this with recursion. We'll do def drill down, and this is going to take a root. Let's call this node, tree node. Do I want tree node to be optional? I think I do. That way I can just return 0 if it's empty. So from here we're going to return an int. Actually, I don't think I need a new function since it's going to have the same arguments and the same return type. I can just use this one over and over. So first I need to check if this node itself is null. So let's do optional tree node. That way I can do if root is none, return 0. So if root is none, return 0. Then we're going to do count equals 0. And then we'll call good node count plus equals good node self dot left plus good node self dot right. Okay. So it's going to call good node on the left and on the right, and it'll get an integer back from each of those, add them together, add them to count, and then it'll return. Okay, I'm going to put this in as a placeholder. It'll return count plus 1. But what I need to do is to pass down. Oh, that's why I needed another. We can still do this. We'll go maximum, call it max val is an int, and it's equal to 0. And then let's see, we'll pass in here max of self.val and max val. I'm letting JavaScript syntax creep in. Okay, snake case. And then here we pass in the max of self.val or max val. And then here, if self.val is it's strictly less than, because if it's equal to, it's still a good node. So if self.val is less than max val, return count, else return count plus 1. Okay, I think this is good. Let's make this a little more clear. There we go. And test. Name, oh, self.goodNode. Oh. Solution object has no, oh, good nodes. Gotcha. Typos will get you every time. Boom. Submit. See how well we did. We failed. What is this all about? Okay, so these are the good nodes? No. There's one good node. Click to view the entire tree. 1, 2, 3, 4. No. Oh, 1, 2, 3, 4. Something like that. I found 5 somehow. So let's say I'm having a hard time trying to figure out how to troubleshoot this. If I print every node as I go through it, it's just going to be a pain in the ass. If I just print the ends, then I'll have no idea if it was a 4 here or a 5 there or whatever. So, let's start here. We'll figure out what the end nodes are. This is root dot val. I guess I could just print root. No. Yeah, root should work. Okay, so I found the 5, the 3, the 2, and the 3. Test case. I found 5. Got it. 5. I found a 3, which is not this one. It's this one. And then I found a 2. Yeah. And then I found another 3. Five, 3, 2, 3. Wait. How about 4? There's supposed to be 5. Okay. So which one did I not find? I found 5. And 3, and 2, and 3. 5 is good, 4 is not. Those are all bad. Those are bad. That's bad. Yeah, I don't understand why they think this should be 5. Wait a minute. Is number 1 should be good, shouldn't it? Why is 1 not good? Oh, that's why. Okay, so this should be float negative infinity. Yeah, it didn't find negative 1 because I had set the lowest number at 0. Okay, most people used more space. Interesting. They used a deck. Looks like basically the same idea. They just went through a deck instead of a recursion. Okay. Thanks for joining me.